According to the National Electrical Code, specifically Section 300.14 at WO, a minimum of 6 inches of unstripped conductor is required to be left at each outlet box, junction box, or similar fitting where a device will be connected. When considering grounding, the two ground wires present within the electrical box must be securely connected to each other. While the NEC does not explicitly mandate 6 inches of both ground wires, adhering to the general guideline of leaving 6 inches of unstripped conductor is strongly advisable. This practice ensures adequate wire length for proper connection to the outlet or switch, as well as any downstream devices that might be connected. Here's a recommended practice to follow. Firstly, strip approximately 1 inch of insulation from the end of both ground wires. Secondly, twist the strip ends together using a wire nut or another approved method for making electrical connections. Thirdly, ensure that you leave at least 6 inches of the twisted ground wire extending from the bottom of the box. And fourthly, make the final connection to the outlet or switch using the remaining portion of the ground wire. However, there might be situations where adhering to the 6-inch rule for each ground wire is not feasible, particularly due to space limitations within the electrical box. In such instances, prioritize using the longest possible length of ground wire available and focus on establishing a secure and reliable connection to the outlet or switch. It's important to understand the reasoning behind these requirements. The 6-inch rule provides sufficient length for electricians to work with, allowing for easy manipulation and connection of the wires. This is especially crucial in crowded electrical boxes where space is limited. The connection of the ground wires ensures a continuous path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. A secure connection is essential for the grounding system to function properly. When stripping the ground wires, it's important to use the correct size wire stripper to avoid damaging the conductor. Damaged conductors can weaken the connection and potentially lead to overheating or arcing. Twisting the ground wires together before applying the wire nut ensures a good mechanical connection. The wire nut then provides insulation and further secures the connection. Using an approved method for connecting the ground wires is crucial. Wire nuts are the most common method, but other approved connectors are also available. Leaving at least 6 inches of twisted ground wire at the bottom of the box provides ample length for future modifications or repairs. If the wires are too short, it can be difficult to work with them and may require replacing the entire wire run. When connecting to the outlet or switch, ensure that the ground wire is securely attached to the grounding terminal. A loose connection can compromise the grounding system and increase the risk of electrical shock. In some cases, it may be necessary to pigtail the ground wires. This involves connecting a short length of wire to the ground wires and then connecting the pigtail to the outlet or switch. Pigtailing is often used when there are multiple ground wires in the box or when the existing ground wires are too short. When space is limited, it's even more important to ensure a secure and reliable connection. Use the longest possible length of ground wire and carefully twist the wires together before applying the wire nut. Consider using a smaller wire nut or other approved connector to save space. Always follow the manufacturer's instructions for installing electrical components. This includes wire strippers, wire nuts, and outlets or switches. If you are not comfortable working with electricity, consult a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock. Before working on any electrical circuit, turn off the power at the circuit breaker. Test the circuit with a voltage tester to ensure that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical circuits in wet or damp conditions. Be aware of your surroundings and avoid contact with grounded surfaces. If you experience any electrical shock, seek medical attention immediately. Grounding is a critical component of electrical safety. By following the NEC requirements and best practices, you can help ensure a safe and reliable electrical system. Remember that local codes and regulations may vary. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes. Understanding the principles of grounding is essential for anyone working with electricity. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, which is connected to the electrical panel. From the electrical panel, a grounding wire runs to each outlet and switch. The grounding wire is typically green or bare copper. When a fault occurs, such as a short circuit, the fault current flows through the grounding wire back to the source. This causes the circuit breaker or fuse to trip, interrupting the flow of electricity and preventing electrical shock. Without a properly functioning grounding system, fault current could flow through a person who comes into contact with the energized equipment, resulting in serious injury or death. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that the grounding system is effective and safe. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes metal conduit, metal boxes, and metal enclosures. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The NEC also requires that all electrical equipment be properly labeled. This includes labeling the circuit breakers and fuses, as well as labeling the grounding and bonding connections. Proper labeling helps to ensure that the electrical system is properly maintained and that any problems can be quickly identified and corrected. In addition to the NEC requirements, there are also a number of best practices that can be followed to improve the safety and reliability of the electrical system. These best practices include using high-quality electrical components, following the manufacturer's instructions for installation, and performing regular inspections and maintenance. By following the NEC requirements and best practices, you can help ensure a safe and reliable electrical system. Remember that electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock. If you are not comfortable working with electricity, consult a qualified electrician. Always disconnect the power before working on any electrical circuit, and test the circuit with a voltage tester to ensure that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical circuits in wet or damp conditions. Be aware of your surroundings and avoid contact with grounded surfaces. If you experience any electrical shock, seek medical attention immediately. Grounding is a critical component of electrical safety, and it's important to understand the principles and requirements for proper grounding. By following the NEC requirements and best practices, you can help ensure a safe and reliable electrical system. Remember that local codes and regulations may vary, so always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes.